what do you consider a simulation versus an eval? How can we look at simulations in general? Because I hear the term thrown around a lot. I was joking with a friend saying, "Oh, simulations are just the new term for evals." And then he was like, "No, but like evals are something you do after the product's out. Simulations are
Mhm.
something you do before the product's out. What do you consider simulation?"
Yeah, yeah, it's a great question, and I saw that discussion, to be curious. I saw the simulations of the new eval discussion. Um, I think of simulations as the process, and
Mm,
eval as, the kind of like, I guess, like, if you think of an eval data set or something, that's a specific, like, product outcome of simulations in some sense. So simulation is basically the process of, mocking users, mocking some execution in some environment before you actually go out into production. Before you enter the real world. And the outcome of simulation is a lot of data, a lot of traces of, like deep, rich traces about what actually happened in simulation. And you get like, a lot of rich data that you can analyze and use for different outcomes from that. One of the outcomes very much talked about these days is training data.
mm,
So you can essentially use these simulation traces to essentially find you want to post train your models to get them more aligned on certain tasks, etc.
mm.
But when you talk about eval, which is I think where your conversation came up, Demetrius, a big thing that you get out of simulations is you can do simulations for the purposes of getting an evaluation data set and seeing how your product performed, once it would go out in production in simulation.
When you say you get all this rich data, what do you mean by that?
Yeah. So if I'm like any AI agent, essentially, um, it's weird. Like, I mean, eval is so talked about and has been talked about for almost as long as, it was one of the first problems that really came up for people building AI applications, using the modern Gen AI stack. And the one of the kind of really hard things, there's a lot of like very challenging things about it, that I've talked about elsewhere as well, including like what even to evaluate. Like earlier we'd have terms like accuracy, etc. And accuracy doesn't really have any meaning in the Gen AI world. What does an accurate, customer support agent even mean? Is it like truthful, etc., or does it mean something else? And you say, there's a lot of issues with it. One of the important issues that is very underaddressed is the data that you test on, right? When you talk about like testing or evaluating a product. And maybe what you're doing is, you are OpenAI and you just care about, like a large conversational model, in which case you have, like the world is your data set, right? There's
Mhm.
so much conversational data out there. But if you're building any sort of an agent or if you're building anything that's, custom or specific to your organization, then it becomes really hard about where am I going to get this data from, especially if this is a new product that you might be launching. So a very common pattern that we see, especially for, AI agents, etc., is there will be teams, maybe the AI engineers, maybe it's, the product owners that are working with the AI engineers or the QA team, etc., that's manually sitting down and writing, scenarios, right? The user is this, and then this is how the model responds. And now the challenging thing about this is that agents, chatbots, etc., they're all multi-term, they're multi-step. So then your data set changes, right? The moment you iterate on your model, your eval set becomes out of date because, your follow-on message now has to change based on how the model changed or how the model differently responded. So this is a big challenge. And so often what we end up seeing is that teams will test their AI agents on a very small volume of data set by any ML or AI standard, right? So AI model are tested on millions of examples. AI data sets are AI agents, etc., are tested on like 50, 100, 200 examples, and then you ship them out. And as suddenly millions of your users are going to throw, like a ton of queries at them, right? So the idea of simulation and getting a lot of this rich data is can we simulate and just get a much richer distribution at a much larger scale in a very cost effective and time effective manner before you ship.
I've seen teams that will create these simulations by hand, and I've also seen teams, and I think it's a common pattern to create synthetic data sets. Is that like a very common way you've seen it too? And maybe what are some of the pros and cons of the synthetic data set?
Yeah, synthetic data is great. I think like simulation, one of the ways to get a synthetic data set is by running simulations. And then, just the asset you get out of it is the synthetic data. But even if you're not doing simulations, you can just, ask ChatGPT and ask it to create a synthetic data set for you. I think it is pretty high ROI. It basically is like very cheap and very, very easy to get started with. And that's essentially um, that's why it's so valuable. I think the challenge often ends up being that in order for ChatGPT to behave like your users, or in order to get your synthetic data to behave like your users, that requires a lot of time, right? So we actually worked with teams that had very well developed AI evaluation protocols. So they'll do like synthetic data. They'll have real, they'll have a crowd as humans that are creating data for them. They will have red teaming services. They will, pay for data, etc. So, they just have a very good protocol. Here is how they see synthetic data is it's a good way to get bootstrap, but it's not valuable down the line.
Mm.
I think a lot of what we tried to do with simulations and with Snowblob is that synthetic data is exceptionally valuable. But when you enter these like chat regimes or agent regimes, it's very hard to get that realism, right? That the users would typically have. So can we build a product that with minimal setup just gets you a very high degree of realism that's much closer to your humans? There's always going to be some gaps there. You'll never get like perfect one-to-one match, but if you can scale it up very cheaply, very quickly, then it ends up being pretty effective.
So I also want to take note of all of these awesome people that are with us. In case anybody has a question, I'm monitoring the chat. Feel free to drop it in there and I will try and get to it and ask Shreya. But my next question, top of mind, is do you view simulations as red teaming?
Yeah, great question. I think there's a lot of these, I would say, adjacent areas that simulation bumps into, right? Like evals, synthetic data, etc. Um, I I think there's some overlap if you configure your simulation to be adversarial.
Yeah.
So, what you can do is you can simulate regular users. You can simulate, your most common users that are just coming to your product or your model and just, interacting with it multiple times over and get maybe a very large quantity of training data set or even, like an eval data set. If you instead configure those users so that they're actively trying to break your system, looking at what are the jailbreaks available today, mixing and mashing them and evolving them, etc. So that becomes red teaming. So in Snowblob, actually, we've been building a red teaming version of Snowblob, which is like strictly adversarial. And it's not
All right.
planning this is an early announcement, but we are planning on like launching that and making that available in product phase.
That's awesome. That is, of course, you're doing that. You're tending to every time that I talk to you, be doing those kind of cool things. And I remember what, like 3 years ago, when you said, sometimes some people like to talk to models that hallucinate all the time, and that can be a feature, not a bug. And that was something that completely turned my head around. Uh,
Mm.
I see there's some questions in the chat I want to get to. Ian is asking, and Ian, thanks for jumping over to the right channel. I appreciate that. What are we looking for exactly in the simulation results? Can you score it at the end? What does that look like?
Yeah. Great question. So this is where this actually relates a little bit to what I was talking about earlier, which is how simulation differs from eval. If you attach, so when simulation is a very good fit for an eval process, is when you attach some scores. So you can essentially same as what you would be doing in an eval product, which is you have some LLM judges, some maybe I don't know, like other static metrics, etc. You can basically create that whole suite and run it on your simulated data the same way you do it on your real data. And you can just do it again at higher scale and before you actually go out into production. So you can check, for example, let's say you're building a customer support agent. What you can do is create a very large volume of simulated conversations where users are asking about, certain different topics. And then see what use an LM as a judge for catching hallucinations, and then see what the rate of hallucinations is in simulation. So it ends up kind of like working out the same way, but the data essentially changes to synthetic.
there's another awesome question coming through here. At what point does the reliance on synthetic data in evaluation pipelines compromise the validity and authenticity of the results? And how do you technically determine that point?
Yeah, yeah. I mean, this is the classic question, honestly. So I've been working in, I think a lot of the inspiration for this was in self-driving cars and robotics, which is a lot of where my background is in. So in self-driving cars, a huge part of the testing pipeline is simulations because of how expensive it is to, how expensive and just how hard to construct it is to create like end pieces, scenarios, etc. So essentially there's this concept of a sin to real gap, which is how different your simulator behaves or models that are created by a simulator behave from, models, etc. I think that it is something to be aware of. What I will say is that in terms of, specific metrics, there's a number of like pretty straightforward things you can do to see how valid or how similar your synth data is to your real data, or if you have any real data at that point. So for example, you can look in, like the distribution across like n-grams, etc., across topics of conversation. You can try to quantify tone and look at that distribution. So a lot of the, if you're familiar with the MLOps era, um, work around like distribution shifts, a lot of that distribution comparison is stuff that you can do between your sim data set and your real data set. I would say even within that, nuance is important. So a lot of times your sim data, let's say you are already starting to get a lot of real data, right? A lot of times your sim data being different and having a different distribution, if done thoughtfully, can actually be an asset. So we were talking about red teaming earlier. So red teaming is a good example of this. Red teaming data will by definition look different from, your normal users, right? Because your normal users are hopefully not trying to break your system all the time. So there'll be an overrepresentation and a lack of mismatch. But that doesn't mean that just because it's different, it's not valuable. It's still very valuable to stress test specific aspects of your product. Maybe you want to simulate specifically, let's say, in your customer support agent, you're adding a new document in your knowledge base that didn't exist before, right? So there's not going to be questions about this before, but you want to test specifically how your system does on that new document so you can simulate ahead of time. That will look very different, but it's by design and it's valuable.
And when you talk about simulation, you're only talking about the back and forth. You're not talking about simulating different environments or simulating user behaviors in the way that, like, maybe it's a slow computer or maybe they're pounding on one link and they're freaking out, the rage clicks and that type of thing. It's only the conversation. Is that right?
Yeah, yeah. So today it is. Today we do simulate lots of different type of users, but the um I guess the interface is text messages, between the users and the system that we're simulating. But I think a lot of this, especially Dimitri was talking about, how I'm very fascinated with what simulations can enable. So I think a lot of this does expand out. The same concept carries over, but the building a product for that and those kinds of simulations might look a little bit different.
Makes sense. So Yvonne's asking a question here in the chat. How do you measure how closely the simulation matches real world behavior?
Yeah. So I think there's two different kinds of things to track here. One is um, if you look at a very large distribution of how people typically interact in with, let's say, a chatbot. And the second is, let's say you have very, you don't care about normal use, global users. You care about users that are very specific that are going to come to your organization's customer support chatbot that you're putting out publicly, right? So those two users are going to be different. I think for the first, we essentially look at like public data sets to look at, like how users typically behave and kind of compare our simulations against that. For the second, it is contingent on having some data available. What we often end up finding is for the AI, like especially with the new AI workflow, a lot of organizations just might not have data available to train on. That data might not be, that might have like too much private or sensitive information. So it might not be, testable, etc. Right? So you might not even have data. So it's very hard to, actually compare how Centurial compares. But if you do have data, then you can kind of run those same like distribution comparison things that I was talking about earlier. And if you share the data with the Snowball product.
Hmm. And there's another great question. This one is great. Rodolfo is asking, are there tools that help to plan, implement, and execute simulations? I got good news for you. I know of one.
Yeah, I love that question. The tool is Snow Globe, available on snowglobe.so, and it does basically exactly that. It helps you create very custom simulations for your product and do it very easily via the web UI and then API support we have. I think a lot of the focus there was how do we make it like really low lift to get these like custom simulations, right? Like simulations aren't by themselves a new idea, but making them so easily adaptable to your domain is the new idea here.
Yeah, I really like the idea of thinking about different slices and how to attack that and seeing the distribution in a very mathematical way as opposed to just vibing it. It's quite useful.
Yeah.
The thing that I wonder about is, do you view simulations for voice
Mhm.
AI and text chat interfaces differently? Or is it, at the end of the day, is it the same?
Yeah, it's a good question. I think there's some so all voice products that we come up against a lot of like voice agents. Almost all voice agents that I've talked to are always a voice kind of sandwich around like a text core. So you essentially do like speech to text and translate whatever the incoming text is into, text. And do reasoning, etc., over the text space, and then do text to speech on the other end. So a lot of it is, kind of like that pipeline. So typically we do find that being able to simulate just text is pretty valuable by itself. I think there's some additional specific things that you can test for um, in that simulation kind of workflow, which is specifically around things like transcription errors, issues with accent, etc. I think those metrics end up becoming like very voice specific, which is how well your like sandwich layers are performing.
Fascinating. Yeah, I can see that. What are some of these other hard challenges with simulation?
I think a lot of them, um, there's so many. I think the thing that kind of like really fascinating to me is how do you make these simulations, like adapt really, really well. So what we've done, for example, is that we try to basically make sure that these simulations are very valuable to you because you can essentially, for example, like connect your own knowledge base and, we mine that knowledge base at scale, create a whole topic tree from it. And then we create questions that systematically target that topic tree to kind of make sure that you're getting the most coverage possible over your questions, right? Or over your knowledge base in your simulated data. So I think there's a lot of amazing things you can do to make these simulations kind of really valuable. I think the things that I'm kind of super excited about are how just kind of like the story between like evolving the simulation based on kind of the insights that we learn. So this is another product that I'm giving a sneak kind of announcement for.
Oh, nice. Two in one.
Yeah, so this one, we're kind of like onboarding some beta testers for it right now. So if you are interested, just reach out to me, email me. I'm sure my email will be shared somewhere. Or is this Shreya@guardrails.ai.com. But essentially the idea is that you can look at how you can essentially look at these like rich data that you get from your simulation and then typically understand things you didn't know prior to running that simulation about your product, right? For example, hallucination is something that came up. Hallucination is a very, very well-known issue of AI models. But every time you're building an AI agent, there'll be, some issues that where you're not happy with the performance that might alienate your users or your customers, but you aren't sure of what it is yet until you see it, right? And that's because it's how unbounded the domain space or the distribution of, text in these modern AI systems is. Now the cool thing about simulations is like if you don't know where it is until you see it, you can simulate it at scale, and then it will come up, and then you'll see it and know how to fix it ahead of time. But the challenge is that manually looking through, okay, what do I not know about my product, and manually doing that for like a very large volume of data can become like very tiresome and very time consuming. So essentially, what we've been doing is, can we take away the manual toil about, okay, tell me interesting things that you found from your simulation as a human would. Like, let's say a human is reviewing a bunch of that, a bunch of those traces, etc. So we're basically building a product that, essentially automatically evolves, like slices the data in interesting ways, and then automatically evolves. Okay, from looking at from analyzing all of these data points, this was some interesting insight that I had that I actually wasn't tracking before, outside of maybe just hallucination. Maybe my AI system becomes very rude when it doesn't know the answer to the question, or maybe it refuses too promptly, right? And then you can kind of like add that as a criteria and then keep evolving what you're looking at as you slice and dice your data in interesting ways. So I think that's super fascinating to me. And I'm excited to see, where we can kind of go with that.
How do you then act on that information?
Yeah, I think the acting on it is you get into towards a very cool thing, which uh is another area which is I'm very fascinated by, which is that if you can automatically identify these issues, can you, then understand, like, can you then start to figure out how to fix it? So I think there's basically like a few different ways to kind of fix AI systems today, right? You can fine tune the model so that it's better at that kind of data. You can prompt tune it, or you can like prompt engineer your system so that it works better on the data that you've seen, or you can maybe add some other kind, like maybe you make your retrieval better, etc. Right?
Uh,
I think there's a lot of amazing work inside prompt tuning and prompt optimization, etc. And that if you can figure out how to improve your system, or if you can figure out what's wrong with your system in simulation, then you can prompt optimize it using like some automated prompt optimization tools, etc. So I think that's an area that I'm pretty fascinated by thinking about it, but I think it's kind of like early to see if you can create like full kind of self-improving loop there.
Yeah, this kind of goes in line with a question that's coming through from Aman, asking about being able to post-train or fine-tune models after you get this simulation data. And um, does Snow Globe help with that specifically? If so, how? And then what other like ways can we grab that data, use that prompt tune, or do things like fine tune on top of it?
Yeah, yeah, absolutely. I think so this is pretty interesting. When we started creating Snowload, it was for the express purposes of making evaluations easier, like helping you catch edge cases, corner cases, the long tail of your users, your user interactions. But very, very quickly, we found that people, our customers were very interested in using it to generate data at scale. That was very cheap, but help them get data for post training essentially. So I think it is pretty helpful in that. We have like some support. Essentially, if you are to like DPO using this data, I think that's very well supported. And we are essentially adding more hooks to the product to get like make it like super easy, get data sets for other kinds of like post training, like distillations, etc., from the system as well.
Hmm. And the thing that I've got a few different ways that I want to take this because there's so many cool things about this. But first, I guess direction is how do you or are you able to visualize the data? Once you have this rich data that you get from the simulations, is there a way to quickly see, oh, here's some outliers or here's some like weird stuff that's going on. Maybe I should inspect that more.
Yeah, 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 there is. We built out a bunch of like visual interfaces to essentially look at your data in a much easier fashion. There's basically a 2D kind of projection of your data points, etc. And I think the other part of it is that we also analyze it automatically, So we do systematically analyze it, and we see, okay, what are your biggest clusters, where they're, like our distribution things, etc. And you get it just as a byproduct of running your simulation, this kind of automated analysis.
How do you see guardrails and simulations playing together?
Yeah. I think they're very, very complementary. So, um, a lot of their initial motivation, honestly, for building Snow Globe was also we were talking to people that would keep asking us, how do I, like, so for guardrails, we have an open source guardrails library, which is the biggest open source, guardrail that you can find anywhere. And as part of that, we actually announced this on an MLOps, talk. But we have a Guardrails hub, which is the largest collection of guardrails you'll find anywhere, proprietary or open source. And then we like the questions we get asked a lot is like, which guardrails do I really need? Like we found that people tended to be very like almost fear driven when thinking about guardrail, which is, okay, I should try to add all of the guardrails, because like that's what this framework tells me, or some other framework tells me, and without really kind of understanding what their risks are, like what their AI agent is good at or bad at. So the idea was for simulations was like, okay, rather than kind of throwing the kitchen sink in terms of guardrails, can't we just simulate and see where your system is good, where your system is bad, and then you selectively figure out, like, maybe your system just never produces toxic speech, which honestly, a lot of modern AI models, are very like unlikely to do that or not
Yeah.
use. Do you still need your toxic speech guardrails? Like, or can you just can you forego it and then avoid the latency that you really are going to add to that? So simulation help you. Simulation happen during development time or test time, where they essentially help you understand the performance of your system better and quantify how your system will perform across different metrics once it's in production. And guardrails kind of is post production, and then the issues that simulation uncovers, you can basically add better guardrails, etc. around that.
Yeah, I can see that. It's helps you not over engineer things because
That's a nice way to put it.
yeah. Now, I want to talk a bit about like environments and how you see those because I know that's a hot topic in the simulation world, right? And trying to figure out how can we simulate an environment for an agent to go and do something, or are you looking through that, or how are you thinking through like environments as far as that goes? And maybe break it down for me because I'm just throwing around uh buzzwords and stuff. I would love for you, who is very deep in this, to help me understand that.
Yeah, so I think the idea with environments is that as in models are expected to get better at certain tasks, um it's basically very hard to, for example, get a foundation model that is going to know how to work an Excel spreadsheet if if it doesn't have a lot of data for Excel spreadsheets, right? And the kind of like different requests that users can have. So can you create an environment where essentially you can just generate a lot of data at scale, a lot of interactions at scale, So there's going to be environments that are very, very specific to the different pieces of software. So there'll be an Excel spreadsheet environment. There can be linear or any issue tracking simulation environment for like for teaching a model how to navigate that better, right? Or they can be an environment that teaches models how to get better at writing presentations, etc. So there's this whole suite of like tools, or like using coding agents, like making better coding agents, like software environments, etc. But the idea is that in order to basically do like RL on it, you need to just have some um I'm using this recursive but have some environment where you can essentially see, okay, if the model takes this action, right? Given some user request or some user stimulus, if the model takes this action, what happens next? Like, okay, how does my environment state change? What actions do I have to carry out next to kind of like get to my goal? And then once you kind of like follow this trajectory, you're gonna end up at like some goal, which can either be good or bad. If you reach a good or an amazing terminal state, you kind of like, back, like you reallocate the reward for that for all actions you took across the path. And if you ended up at a bad terminal state, you reallocate that reward. And that essentially helps you uh, train a model that basically ends up as a feedback signal to train your model to become better at, certain tasks. So that's sort of very high level, like the idea behind environments. I think it is very closely tied to the idea of simulation, which is, that yeah, it's basically kind of like, almost an essential tool that you kind of need, I think how we think about what Snow Globe is really good at and what Snow Globe does. So Snow Globe right now works out of the box for chat, environments, right? And as you can imagine, for chat, the kind of space of actions is much smaller, which is, okay, just the model response and text. But like we'll update the human response, which is our environment. I think a lot of like our focus is on Snow Globe, like is to how do you explore this space efficiently, for the purposes of like either training data or evaluation data, right? So it's not just sufficient for there to be a state machine where the user generates a message, the model responds, and the user is able to update and evolve what they need, but that we are able to generate like more and more examples that have very wide coverage over the space, right? And that idea also carries over to environments. Like if you have an environment which is an essential tool, but you keep exploring the same kind of like set of requests, etc., then that's not, it's not giving you a lot of bang for your buck, right? So I think like where we want to take Snowball is basically make it a good tool to kind of like explore environments in this richer kind of fashion so that you get better kind of data, etc.
Do you have it's always hard to say definitively, but maybe you have a framework for how you look at how many simulations you need, how much data you need, especially if then you later want to act on it or you want to feel confident that like, all right, let's push to production.
Yeah, it's a great question. So, we like it does depend on where you are. So typically, what we end up finding is, let's say you're building a new AI product from scratch, right? Typically you'll start out with like not having any real data. So what you can then do is like, okay, you run, for example, a large simulation, which would maybe be about, like let's say 1,000 or 5,000 simulated scenarios. And in each scenario might be, for example, a multi-turn conversation, and the goal of your simulation is just normal users. So you just want to simulate, like you just want to simulate a wide distribution and just get, establish a baseline almost. And then from that baseline, you're going to end up discovering, okay, actually, maybe my system does very well on, XYZ queries, or on, this like type of like W queries. It doesn't do as well, right? So then you're going to keep updating maybe some prompts, etc. But the scope of your simulation is much smaller. Maybe it's, like 100 or 200 examples, but that very targeted at, only the W kind of query. And you keep simulating them multiple times over. Every time you put a new PR request or something, you do that simulation and just see how it essentially do a comparison between, previous versus current performance. And you keep kind of like evolving that. And then finally, when you're getting closer to production, you expand the scope of that simulation again, where it's much more, targeted at like, okay, what's my overall distribution? And maybe also around red teaming, which is like, okay, now I want to move from, my normal users to just my worst case users and see how my system performs.
So that's fascinating. It's basically let's go as wide as possible. Let's find the problem areas. Let's really hammer in on those until we're confident and then open
Yeah.
up the aperture once again before we throw it out. Now that's a from 0 to 1 type of thing. Is the I'm already in production and I just want to fine tune that. Is that more just finding those slices?
I think a lot of it is around regression testing, you know. So this kind of goes a little bit beyond simulations, but one of the things I highly recommend is having some rubric or criteria for what good performance for your AI system looks like, and grounding it in, like some, let's say you're like, okay, my model should always be empathetic to user requests, right? Like what is like create that criteria, and then, have some examples or something. I think Anthropic's constitutional AI was kind of like a landmark, work in this, very early on, like maybe even as early as 2022 or something. I don't remember exactly the year. But the idea to kind of create a similar constitution for your work, right? And then once you have that and you have a model in production, you can basically keep regression testing. How is my system doing against my custom constitution? And essentially do that. So I think that's typically what we see it. I think another thing we see is that, okay, we saw this maybe failure in production that we weren't sure of. Can I automatically then, simulate a lot of users with this specific request or something, and then just see, is this a one-off issue? Is this a, persistent, systematic problem in my model? And then how do I kind of fix it?
Yeah, it feels a way like CI/CD kind of pipeline that you would need to do.
Yeah.
And does it take a long time? Like if I'm going to push a new change
Mhm.
and I need to run these tests or I need to run these simulations,
Mhm.
is it like I need to come back tomorrow or does it happen quickly? How does that work?
It does depend. It is typically pretty fast. Like you'll typically in 15 minutes you'll get like 100 simulated scenarios. Caveats. So it does depend on the size of your simulation, and it does depend on, oftentimes they'll be throttling from your models end, right? Because think about it, we're running a bunch of parallel sessions against your agent. So your agent might also have some throttling requirements, etc. So we often find that we're constrained by the user's kind of usage limits.
Yeah.
The Google users' usage limits.
Does there need to, so you run the scan after we do the simulations, you kind of surface different issues if they're around. How much then do I need to go and inspect that data also and really try and figure it out? And then also, am I labeling that data afterwards? Like, what have you seen the best teams doing to get the most bang for their buck?
Yeah, we actually did see a lot of this. So we built some. um, right now in Snow Globe, you do need to go in and look in the data yourself. We'll analyze it, we'll slice and dice it, we'll cluster it, but you do need to look at it, to kind of find your unknown unknowns, especially, right?
Mhm.
If you already know that hallucinations, jailbreaks, and toxic speech, those are the three things I care about accumulating against, then we'll surface metrics for you. But there is a lot of alpha in just looking at those traces by yourself and, understanding what are the issues in my system that I'm not even tracking yet. Um, so the best teams today do look at the data, and to help support them better, we added labeling tools to it. The new product that I kind of like spoke about earlier, right? That kind of like automatically evolves this. I think with that, the goal is, can we eliminate the need for looking at your data, which is still continues to be, especially, like you're just still limited by scale, right? You can't do it at large scale. So, and you just keep developing with like 20 scenarios, etc. So with that, the idea would be to just look at the report at the end and then, get your info from there.
And do I just hit an API? Do I push a new agent out and as part of my CI/CD test, I have it as one of the steps?
Yeah. So yeah. I would say, like, especially if you want to run this in CI/CD, try to have your what do you call it, like simulation intent, what you want to simulate. You should know that ahead of time, right? And so try to do like one or two in the web UI, and then everything that's possible in the web UI has an API that supports it. So then you can basically set up an API that basically runs that same process, periodically, maybe weekly, maybe at every PR if you want it to be, etc.
Yeah, this is a fascinating world for me because it is so needed. And I've seen so many folks that retroactively think about this, or they realize that, oh, wow, our model or our agent is doing something really weird and we're getting customer complaints. And so it's a great way. It makes a lot of sense that you were talking to folks about guardrails. And as part of that, you started to see, well, maybe we could preemptively do this as opposed to guardrails. I think of something at the end of the life cycle.
Yeah.
Simulations, I think of something at the beginning of the life cycle.
Yeah, exactly. And I think a lot of like both guardrails and simulations are very inspired from, self-driving cars, and just um I think in a weird way, I think like AI agents are most similar to, robotics or self-driving cars style of AI research rather than a lot of what we're doing in the past, right? Like machine learning or Rexis models or classification. There's not a lot of overlap between that and agents, but there's between robotics for self-driving cars and AI agents. And I think in that way, I've been very fortunate to kind of like having worked in that space, just knowing, that space had roughly a 10-year head start on Gen AI. So we could just see, right? Like, what are the patterns? What are the issues we ran into? What are the patterns that, after a lot of trial and error, end up evolving as successful? And then can we build those parallels for the Gen AI world? So guardrails are something that came from that, and simulations as well. And I think they work really well together.
Yeah, one thing I think about a lot with the self-driving cars is those unknown unknowns. And you see, usually when it happens in self-driving cars, you get like videos and memes about it where maybe there's a bike on the back of a car and the self-driving car doesn't know that because they've never seen a bike on the back of a car. Or I joked because I was in San Francisco at the beginning of September and I saw a guy in the beautiful district of the Tenderloin walk out in front of a Waymo,
Mm.
and she took off like a COVID-19 mask and put it over one of the sensors because the Waymo had to stop. But there
Oh,
was a human that walked in front of the car, so it stopped. The
yeah.
guy put his mask over one of the sensors and it just bricked out the whole car.
Yeah. Yeah.
And and it's like that was not in the training data.
Yeah.
And that kind of thing, in a way, yeah, simulations ideally will help get that, or it will help kind of figure out the contingency plans if these
Yeah.
random one-off things, because you can't simulate everything, but you
Yeah.
can start to see the edges of what you're capable of.
Yeah, 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 absolutely. I think I suspect that that wasn't in the training data. I think you'd be surprised by like how many in self driving, how many of these things, there are teams whose job it is to kind of like think of this stuff and then essentially make sure that you have coverage over them, right? And even with that, I suspect that this may or may not have been something, like the breaking the car was the right thing to do as a response to that. So a lot of times, like the goal of simulations is like, okay, I just want to make sure that my system fails gracefully. Like I just want to make sure that when that happens, my car doesn't like freak out and start driving with like poor information, but it actually does break, which is amazing. Make sure that that happens. But I think it's pretty wild to see just the scale that simulation can operate at. So I think like a very common like and fun statistic I enjoy quoting is that I think Waymo at one point had 20 million miles of driving on real road, which is crazy. And then it at the same year, like during the same point, their miles in simulation were 20 billion, right? So just the level of like scaling you can do, and as you're doing that, just better data, more coverage, etc. Is
Well, and there's a parallel there with there's teams, hopefully at your company, or if you're putting an agent into production, you should be thinking about different ways that this is going to fail. And ideally, you're then taking that and trying to simulate for it so you can see, can we fail gracefully? I really like the way that you phrase that. We want to make sure that we're failing gracefully. We're not having this agent go off the rails and do things it shouldn't be doing, or saying things it shouldn't be saying. And let's make sure that if we have some, whether it's a nefarious attack or just an accident and something doesn't work out, we want to not ruin our brand reputation because of this chatbot.
yeah, yeah. I agree, and I think the thing I'll add there actually is I hear a lot of that, which is that okay, I especially for large organizations that we don't want to end up in the headlines.
Mhm.
Which has happened, right? Like there's so many headlines about ChatGPT this for this company and for a lot of organizations, there can be a lot of brand risk around it. I want to say that an under discussed aspect of AI testing is the product behavior of your AI agent, right? Which is again like a lot of software product metrics is it can maybe be like, it has to be very custom often and it has to be very engaging. But things like if I'm building a coding agent, how good is it at understanding user intent, or if it's unsure of user intent, then clarifying with the user intent. Or from building an AI companion, is my AI companion engaging,
Mm.
like not that it feels or not that it, is going to like say something really nefarious to the user, but is it actually fun to talk to? And I think a lot of that is under discussed and hard to quantify also at times. Where like I think the idea with simulation is like really nice, right? Which is like you can test the engagingness of your AI companion in simulation, like multiple variations you can
Yeah.
test out what they perform against each other in simulation without actually maybe alienating your real users.
Well, even a talk that we recently had at the New York event that we did was about how hard it was to get the agents to utilize all of the information that it had. All of the, let's say it had 10 documents and it would just grab one of those documents and then whether or not the answer was in that document, it would be like, yeah, yeah, we got it. We're good. Here it is. Or I have access to these 10 tools, but I choose one and I go with that. And then I know it's getting better with the reasoning models and being able to loop back over it and having different constellations of agents or models being there to double check the work. But that's the perfect case for being able to simulate that and say, like, is it doing what we want it to do when we
Mhm.
ask for this simple task that's like 80% of the use case of this product is this task. Like somebody needs to do XYZ. So let's make sure that this, when we simulate that, it performs that as high a percentage of time as possible.
Yeah, yeah. I think like a lot of what you're talking about is like distribution level metrics almost,
Mhm.
Like so a lot of okay, I don't want it to say something bad is like a one off, it's a single scenario level behavior, right? But okay, does it only is it very biased towards only calling the same tool is something that's very, like distribution level. Like you need to look at a large amount of data to kind of like analyze that, right? And I think the fascinating thing about it is that you can simulate different cohorts and then see how that distribution evolves. So you can basically like, let's say you have 10 tools that you want to use, you can, because we're in simulation land, we can systematically generate scenarios that test out every configuration of every one of those tools called, like like with the intention of those tools should be called in order to answer the scenario. And if those tools aren't called, then you end up getting, okay, something's wrong with my system. I need to go back and change things.